So lately we have been hearing about this whole agentic AI thing, right? So in this video, I'm gonna show you how to build one. Yes, a real agent, that too by just using Python. Firstly, I'm gonna give you a quick idea of what agentic AI is, how it works, or how cool it is. Then we will build a simple AI agent using Ollama, ChromaDB, and Langchain. And even we will add RAG, that's Retrieval-Augmented Generation. And you know what the best part is? You don't need any paid API key, cloud setup, or anything. It's 100% local and totally free. I know some terms sound kind of scary, but trust me, stick till the end and you will get the whole picture. So yeah, let's get started. Alright, before we get into all the technical stuff, let me quickly show you what we're gonna build today. So here is a CSV file in my left. It has over 500,000 customer reviews and ratings for almost 1,500 hotels across Europe. Pretty huge, right? So we have got columns like the hotel name, the positive reviews, the negative reviews, basically a whole bunch of useful information. Now here is the fun part. We're gonna build an AI agent which is gonna go through all of this and help us find the perfect hotel based on our personal needs, or also it can make some recommendations as well. Okay, so now let's run the main script first. It's gonna start in a bit. See, it's asking us to put some questions here. Now, like let's say I ask which hotel, I hope it's visible enough, which hotel has the best sea view. It's fetching the information from the document, and boom, the agent gives us a detailed answer and even suggesting option and pulling the actual reviews. Oh, amazing. Now let's ask another question. Which hotel has the best pool? I am a swimmer, so I'm gonna ask it. And look, it gives a clear, customized response based on what it found in the reviews. So yeah, that's what we're going to build today, a smart local AI agent that reads your data and gives answer like a helpful travel buddy. Okay, now before we jump into the code, let's understand what agentic AI actually is and what makes this kind of systematic. So let's say a few years ago, if I had this question that what's the best hotel in Paris, what would I have done? I would have Googled it, clicked through like 17 blogs, opened like 12 tabs, compared reviews, took notes and whatnot. But Google didn't know me, my travel dates, my taste, my vibe. So yeah, it was manual, messy and time consuming. Then came the LLMs that we use today, like the GPT or the Claude. So what is LLM? LLM stands for Large Language Model. But how do they work? Let's see an example. Suppose you have created a robot here. Let's give it a face. Now this robot at this very moment doesn't know about anything. Then you fit a lot of books, a lot of websites, blogs to this thing. So after going through all these resources, now this robot has become very intelligent. So next time as a human, when you're gonna ask something to it, it's gonna give you a response based on the things it has seen and learned during the training phase, based on the training data set. This is our training data set. Okay, so if you ask it what's the best hotel in Paris, it will give you a decent answer based on what it has seen during training and what it remembers from chatting with you. But what if you wanted to consider your exact requirements? It might struggle because it hasn't seen your data and it doesn't know anything that happened after it was trained, like info about any new hotels that were made after the training, right? And that is where RAG comes and saves the day. Okay, so RAG stands for Retrieval-Augmented Generation. Now, before understanding RAG, let's revisit the problem that we were facing with LLMs. So, LLMs like GPT are being trained on large volume of internet data. So, whenever we ask any query to this LLM, it's gonna answer us based on the data it has seen during the training phase. But in our case, we have this CSV file containing about 500,000 hotel reviews of the Europe. And this data is being collected by us, by the hotel authorities. And as this data is private, so it's not available in the internet. And that is why the LLMs don't have access to this data. As a result, the LLMs cannot answer us accurately about the hotels, because the way the customers reviewed the hotels was more detailed, right, than any reviews available on the internet. They mentioned about even minor inconveniences or even about the positive sides of the hotel, which is not there in the internet. So, through RAG, we're gonna build a system through which the LLM will have access to this private data, our customized data set. Okay, so to understand that, let's see the architecture of the RAG system. So we will start with the data set. In our case, this is the CSV file containing the hotel reviews. Okay, so then we will convert this CSV file into some chunks. In our project, we're gonna call it as separate document objects. Okay, after that we will pass those chunks through this embedding model, and then each of the chunks will be converted into some vector embeddings like this, and that. Now let's understand what vector embedding is, right? Okay, so imagine vector embeddings as a list of number which represent the meaning of a word. Let's visualize it. Suppose the vector embedding of pizza is like this: 1.2, 3.9, 4.2, etc. I'm just assuming it, right? Now let's take another embedding. So suppose the vector embedding of pasta will be somewhat like this, maybe 1.6, 3.1, 4.8, etc. Now see, both these embeddings have kind of similar values, right? Why is that? Because both of these words kind of have the same meaning, right? Both of them are like fast foods, both are originated from Italy and stuffs. Okay, so now let's imagine a vector space. So suppose this is a vector Now in this space, suppose there is this embedding of pizza, let it be X, and let the embedding of pasta be Y. So see, the embeddings of X and Y are kinda staying closer in this vector space because they have the same meaning. Now let's see another example. Suppose there is this another word, a dog. So let's think the embedding of dog is something like this: minus 7.2, 9.1, 2.3, etc. Now see, the embedding of the dog, or the least representing dog, is a way different from the embeddings of pizza and pasta here. Now that is very normal, right? Because dog doesn't mean the same thing that pizza and pasta mean. So the embedding of dog will stay far away from the embeddings of X and Y. Let the embedding of dog be Z in the vector space. To sum up, vector embeddings of words having the similar semantic meaning will stay closer, and the vice versa. Now let's go back to our RAG pipeline. Okay, so we are converting each of these documents into some vector embeddings, and then we're gonna store all of those embeddings inside this vector store. Cool. Please notice that we're also passing the query through this embedding model. So this query is also being converted to a vector embedding now, right? So at this moment, the vector store contains the vector embeddings of those chunks containing the reviews, and also the vector embedding of the query. Okay, then we're gonna perform a similarity search. Similarity search. Now this can be done in many ways, but for your understanding, let's think of this in this way. Suppose the embedding of the query will stay closer to the embeddings of those words, of those reviews which contains the answer of the query. Okay, let's visualize it. Okay, suppose there is a query. What's the best hotel for Italian foods? Okay, so see, when this query will be converted to a vector embedding, note that there is this word Italian. So as the word Italian is related to pizza and pasta, so maybe the embedding of Italian, suppose that is M, will move closer towards the embedding of X and Y. Why is that? Because this three is related to each other semantically. I hope this is clear. So in that way, whenever we are performing a similarity search, we know that which reviews are related to our query, and in that way we are gonna fetch those reviews which are relevant to our query here. So in terms of RAG, this is basically retrieving. So this is the R part of the RAG. So after fetching, after retrieving the relevant reviews here, see, we are combining it with our original query. So what we're doing, we are fetching the relevant reviews first, and then we are combining it with our original query, and that is called the augmentation. Fine. And then we are gonna pass this augmented or this combined data to the LLM so that it can generate a response for us like the way humans talk. And this part is the generation. So you see, I'm just summing up the whole thing. First, we take our data set, we split the data set into some chunks, then we pass those chunks through an embedding model, and eventually those chunks get converted into some vector embeddings, and we store those vector embeddings inside a vector store. So inside the vector store, the vector embeddings of words having similar meaning stay closer. Cool. And then we're passing our original query through this vector embedding, and the embedding of the query is also getting stored in the vector store. Then we're performing a similarity search. So through similarity search, we're gonna find the vector embeddings similar to the vector embedding of the query. In that way, we know which are the relevant reviews for our query. And then we're gonna fetch those embeddings here, those relevant reviews here, and then we're gonna augment that with our original query. Later, we are passing that augmented or the combined thing to the LLM so that it can generate a response for us. It's quite easy. You just need to review this pipeline over and over again, and it will become crystal clear for you. So yeah, that is it. Now we know how LLMs work, what are the limitations of LLM, and then how RAG is addressing that limitation. Now it's time to understand what is an AI agent and how we're gonna build this AI agent today with the help of RAG. So let's jump over to that. Okay, so we are finally here. The last topic of our today's discussion, which is AI agent, the thing we all are trying to make badly. Okay, so what is an AI agent, right? So the ChatGPT or the Claude that we use from our day-to-day life are all AI agents. Think of it like a robot which can perceive and then reason and decide after deciding it can take actions accordingly to fulfill our goal, and if it makes some mistakes, it should learn from it, and yes, the cycle keeps going on like this. So when a robot is capable of doing all these things independently, we may call it as an AI agent. So from the beginning of our video, we have been talking about feeding LLMs some context, right? That LLMs are being trained on internet data and it doesn't know our context and all. So for that we used the RAG architecture. So when the LLMs are being fed our context, we are going to use that LLM as the brain of our agent. This is the brain. Now, it's not enough to have a brain only. We need to store certain things in our brain, right? Like we need to have a memory, of course. So, as the memory of our agent, we are gonna use a vector database that we talked about, and the database we will use in our project is the ChromaDB. I guess it's a new thing to some of us because we are, very used to using the relational databases like SQLite, MongoDB, and all. But this is the first time I will teach you how to use ChromaDB. Okay, now having a memory is not even enough. We need to know how to use our brain and memory, right? So we need a planner, we need some tools, and that is where Langchain comes. So Langchain is going to be the tool that we will use to do all these things. Now Langchain is one of those tools in the current world which is the most tempting, most demanding. Every developer I know has learned or learning Langchain. So yes, it's one of those amazing A-star tools. So we will be using Langchain today as well. So yeah, this is all about an AI agent. It will have the LLM as the brain, where we'll have a memory. For that, we're going to use a ChromaDB, and then there will be a Langchain, which is a software framework, by the way, that we will use to do all the stuffs. Now, yes, so now there is another term known as the agentic AI, which is basically a whole system where multiple AI agents work for multiple different purposes and to accomplish a certain goal. But in our project, we will be building a single AI agent, as we are just starting, right? We're just starting to learn what is this whole agenting thing. So yeah, that's all about it. We have done a long discussion today. Now let's get started with the coding. Okay, so the first thing that we're gonna do is install Ollama. Now, what is Ollama? Large language models like Llama are usually stored on powerful servers and accessed over the internet, like how we use ChatGPT. But with Ollama, we can run the same models directly on our own computer without needing the internet. So let's head over to ollama.com. You will see a big download button here. Just grab the version for your operating system and then just install it. Once it is installed, you will be able to open up that in your terminal or command prompt and type Ollama like this. And if this works for you, that means you are good to go. Now that we have Ollama installed in our PC, let's download the actual model that will do the talking, kind of giving our agent its brain, that is an LLM. We will start by pulling Llama 3.2, a well-balanced model that works well on most modern machines. So let's type Ollama pull Llama 3.2. See, it's pulling the model. Alright, it's a success. You can also explore other models from Ollama's model library, but for this tutorial, Llama 3.2 will do just fine. Now, we also need a second model. This one won't talk to us. Instead, it turns our texts like the CSV file or the queries into vector embeddings like I mentioned before. What was vector embeddings again? Vector embeddings was just smart numerical representations that our agent can understand and search. So let's pull an embedding model called MXBAI embed large. So Ollama pull MXBAI embed large. See, it's also pulling the model from the Ollama library, and it's also a success. So this model is relatively small and should run fine even on a mid-range machine with a GPU. If you were using a CPU-only machine, Ollama still works, but you will want to stick with smaller models like Llama 2.7 billion or smaller for performance reasons. So once both models are downloaded, we are ready to write some actual code. But point to be noted, Ollama should always be running in the background while we are writing code somewhere else. So yeah, let's now jump into coding. So now that we have already downloaded our LLM and the embedding model, we are all set to do the coding. For that, I have already downloaded the CSV file containing all the reviews here. And now I'm gonna create a new folder and name it as Hotel AI Agent. After that, I'm gonna move this CSV file to this folder that we just created. Cool. Now just open any code editor that you like. I'm gonna open Visual Studio Code, also known as the VS Code. In the top left, there is a button known as File. Just click on here and you will be able to open the folder that we had just created. We created the folder in the desktop, so let's go to desktop. And the name of the folder was Hotel AI Agent. Yes, this is the one. Select the folder and here it is. So you can see the folder already contains the CSV file. Okay, now let's get started with actually using a local LLM powered by Ollama. For that, I'm gonna create a new file here and name it as app.py. Now inside app.py, first we are going to import a few things that we will need. So from Langchain underscore Ollama dot LLMs import Ollama LLM. Then from Langchain underscore core, it should be in the next line, underscore core dot prompts import chat prompt template. Now, if you are not familiar with Langchain, it's a powerful framework in Python that makes it way easier to work with language models. It supports a bunch of extensions, including the one we are using here to connect directly with Ollama. Now, what Ollama does, just to recap, is it just runs models locally right on your own machine, and it exposes a lightweight HTTP REST API in the background that you don't need to understand. But that basically means when we call a model from Python, we are not going to the cloud. We are literally talking to the model running on our own computer. Pretty cool, right? Now let's initialize the LLM model that we downloaded. Initialize. So the model we pulled from Ollama library was, actually let's write Ollama and then the name of the model equals to, we pulled the Llama 3.2. Make sure you write the name of the model exactly what it is, otherwise you are gonna get error. The next step is to create a template. Basically, this is how we tell the model what kind of task it is doing. For this example, we will structure it to make the model act as a hotel expert. So template equals to and then you are an expert in answering questions about the hotels in Europe, and you make just good recommendations. Okay, so then we are gonna pass the reviews. Here are the relevant reviews, and then here is the question to answer, and there will be the question inside this. So basically, let's put the reviews inside this curly braces and then the questions inside this, which we haven't declared yet. Okay, so now that we have our template, we will turn this into a Langchain prompt template. We will use a chat prompt template to wrap it. So wrapping it, and then prompt equals to chat prompt oh, we imported the wrong one. It should be chat prompt template. Okay, so chat prompt template, and inside this dot from template, and inside this we're gonna pass the actual template we created. This makes it easier to plug in dynamic data like reviews and questions and get structured responses from the model. With the prompt template ready, the next step is to create a chain. This is where things get connected. We will pipe the prompt into the model using a simple syntax. So, chain equals to prompt pipe model. This chaining allows the system to take inputs, that is the reviews and the question, apply them to the template and send the result to the model and return the final answer. So all in one smooth flow. So to summarize, we have created a template with placeholders for reviews and the question, wrap it inside a chat prompt template for structured input, and then chain with the prompt and the model together. Finally, when we pass in actual values for reviews and question, the model processes everything and gives us a response. Now, as we are gonna ask multiple questions to our agent, like the way we chat, so we will be needing a loop. So now let's build a simple loop so users can continuously ask questions. So loop. We will start by setting up an infinite loop using the while loop. So while true, inside the loop, we prompt the user to enter a question. So question equals to input. Please ask your question. Along with that, we let them know they can type Q if they want to quit. So press Q to quit. Otherwise, as it's an infinite loop, it will just keep going on. So if the user types Q, if question equals to Q, then we just break out of the loop. Cool. So if they enter any other questions, we will invoke the chain as we set up earlier, the one that passes the prompt into the model. So chain dot invoke, and inside this we are gonna put curly braces. That's basically a dictionary with the required variables. In our case, the variables are reviews and the questions. So reviews. For now, the reviews are empty lists as we haven't passed the total reviews inside it. And the question, this is basically the question that you have just typed in. That's the user have just typed in, like here. And once the model processes the input, it gives us a response. We then print out the result. So we have to also store this inside our variable. Let's name it result. And once it just gives us a response, we will just print the result. Okay. And with that, we have created a simple interactive loop where users can keep asking questions and the model will keep responding until they choose to quit. Now when we run the script, we will be able to chat with our LLM as much as we want, totally offline. So just to recap, we used Langchain to build a prompt and a chain here, and then we connected to Ollama, which is already running locally in the background, right? Okay, in the next part, we will start hooking up vector search so that we can pull relevant context from documents and get much more accurate results. Alright, now that we have already created our model and invoked the chain, now it's time to convert all these data into vector embeddings. For that, let's create vector.py. So inside this file, what we're going to do is we're going to create a vector database where we will be storing all these data in form of vector embeddings, so that it becomes easier to look up the relevant information and pass all those reviews here to the model so that the model can give us some contextually relevant replies. I know LLMs can by itself generate text and answer our questions, but when it becomes more aware of the data, it gives us more relevant information. Okay, so for doing that, we will start by importing some necessary things. So from Langchain underscore Ollama, import Ollama embeddings. This is going to embed our documents. Then from Langchain underscore Chroma, import Chroma. If you remember, I mentioned about Chroma once before. It's basically the database store where we're gonna store the embeddings. And then from Langchain underscore core dot documents, import document. So okay, it should be in the next line. So in this through this thing, we are gonna make or prepare our data set for embedding, and then import OS for better file handling, and then import pandas as PD. This is basically for reading the dataset in a more structured way. Okay, so first things first, we need to obviously load this dataset. So for that, we're gonna use pandas. So let's create a data frame, df equals to pd.read CSV. We are gonna read the CSV file, so we have to write the name of the file, which is hotel underscore reviews.csv. Make sure you get the name of the file exactly as it is inside the project directory, otherwise you will get error that file cannot be found. Okay, and then we have to initialize the embedding model that we are gonna use. If you remember, we have already downloaded it. So embeddings equals to Ollama embeddings, and inside this the model name, which was model equals to mxpai dash embed dash large. Okay, so after that we have to also store this database somewhere, right? So we have to specify the location as well. So specifying the location, which is db location equals to dot chrome underscore langchain underscore db. That's it. Cool. So the thing is, we are gonna embed this database and then store it there. Now before proceeding, we have to check that if already these data set has been converted to vector embeddings already. If it has been converted to vector embeddings, then we don't need to redo the whole thing. So let's checking if data db has been embedded. So if it has not been embedded, then we are going to proceed ahead and convert all our documents to embedding. So add documents equals to not os dot path dot exists, and we will just pass the location of the database. Okay, cool. All right, so through this line we were basically checking that if our CSV file has already been converted into vector embeddings. So if it was, then you would have got here false, and if not, we will get here true. So if we get true, that means we are yet to convert that CSV file into vector embeddings. And if you remember from our previous discussion that the first step to convert a dataset to vector embeddings is that we have to prepare the data into some separate document objects. So let's do that. Prepare dataset. So the first thing, if add document, means if we get true from the line 16, we are gonna create two empty lists, documents, where we're gonna store all the document objects and IDs. In this list, we are gonna store the indexes of those specific documents. Okay, so let's create a loop for I comma row in df dot iteros. So what this loop is gonna do, it will go through or iterate through all these rows separately and only grab the information that is required. Okay, so inside this document, we are gonna create the document objects here. So inside document, we need to pass two things. one is page content. So inside page content, we are gonna pass those features or those attributes only that we want our query to be based on. For example, if I ask what's the best hotel with the best Mexican food, then I should go through the positive reviews, negative reviews, or the features of the hotel, right? We have nothing to do with the scoring or the postal numbers or stuffs like that, right? So we're gonna pass the name of those columns only that we want to be considered in the row in the current row we are in. So for example, row, and then the hotel name, which is an important thing, right? If we want the model to return us a hotel, we would be needing the name obviously to know which hotel it is referring to, right? Okay, then plus space plus another thing we would like to go through is the positive review. We want our model to go through, right? So positive review and also the negative review. I'm gonna just copy and paste it here. Cool. So along with that, we're gonna pass another thing, which is the metadata. So what is the metadata? Metadata are basically the additional information we want to grab from this file, but those information are not the specific information we want our query results to be based on. For example, the metadata can be like, you know, the rating of the hotel. So see, I have used a curly braces here, and inside that the rating, which was basically the reviewer scorer column. And also maybe the date as well. Like days since review. See, this two thing has nothing to do with the thing that which hotel has the best Mexican food, but still we're grabbing this informations to make our LLM well informed, right? So yeah, that's it. And then we have to append these things inside this document and IDs list. So documents dot append document and IDs to append the IDs. Okay, so I have missed one thing here. We have to also convert the ID of that specific row into string. So the ID basically means the index of this current row in the CSV file. So yes, we have this two lists filled, like the document list is now filled with the separate document objects for each row, and the IDs list basically contains the index of those rows. So as we have already prepared our data into some document objects, now we have to pass it through the vector store. Before that, we need to create the vector store, right? So let's create. I really hope it's visible enough. Okay, so create vector store. So like vector store equals to we have already talked about this, that we're gonna use Chroma today. So Chroma, inside that collection name, let's name it as hotel reviews, and then persistent directory. So it should be persist directory, and it's basically the DB location. This generally means how we want this database to be saved. We want this to be saved persistently. And then the embedding model that we're gonna use, embedding function, which is basically we stored the model here inside embeddings, right? So embeddings. So yes, that's it. We have also created our vector store. Now it's time to pass our documents inside through this vector store, so that those documents get converted into vector embeddings. Pass docs inside the vector store. Okay, so if add documents, then it should be vector store dot add documents, and the documents will be the documents list, and the IDs will be the IDs list. It might look confusing at some point, like why there are IDs or why there are documents, but it's just how RAGs work. Okay, so we have also created our data set as vector embeddings. Now it's time for our LLM to make use of this vector embeddings. Okay, so we have created our vector database. Now we have to make sure that this vector database is accessible and usable by this LLM that we created before. For that, we're gonna need to create a retriever. Okay, so for that I'm gonna write retriever equals to vector store dot as retriever, and inside this we can pass some arguments like search underscore keyword arguments. What it does is basically it specifies the number of relevant documents that we want to look up. We can use 5 here as I used before. Okay, so this 5, I have used 5 here. You can specify any other number. It doesn't matter. It's just gonna fetch those specific reviews to present to you as the result. Okay, so as we have created the retriever, now we have to make sure that this retriever is accessible by this app.py. For that, I'm gonna write from vector import retriever. Cool. So there was an unfinished word here. See, in the although I have passed the question in to this model we created earlier, but we couldn't pass any reviews here, right? So let's do it now. Reviews equals to retriever dot invoke, and inside this we're gonna pass the questions that we want to make the search with, right? Okay, there should be one end. Okay, and then we're gonna put this reviews here, and then let's erase this thing. Okay, cool. So let's just recap what's gonna happen here. We are taking a question from the user, and then in this reviews, what we're gonna do is we're gonna pass that question. So when we're invoking the retriever, it's gonna automatically embed this question into a vector embedding, and then it's gonna pass here in this vector database. And then by performing a similarity search algorithm, it's gonna fetch top 5 relevant reviews and gonna pass it here in the result, and then we're gonna just print the results. Yeah, that's it. That's all about it. Then let's save the file so that I can, run the main file to see that if it's actually working. Okay, so you can see I have added some hyphens and all in app.py. It's like, just formatting the script so that our outcomes look more clearer. Now we need to create a virtual environment before installing dependencies. So we will go to terminal, new terminal, and then as I am using Windows, so I will write dot v slash venv slash scripts slash activate and enter. See, venv is there, means the environment has been activated. Now you can write the dependencies in a requirements.txt, but I will do it manually here. For that, we will just write beep install Langchain, Langchain Ollama, Langchain Chroma, Pandas, and NumPy. And then press enter. See, the installation process has been started. It's gonna need a couple of minutes. You just need to have patience and sit there. Okay, I guess I will come back when it is finished. Okay, so you see all the installations are completed. So now we have to run our agent. So I will write python app.py and enter. It will take some time. You need to be patient and just keep praying that your agent runs successfully. Okay, so you see the agent has ran successfully. It's asking us to put a question. So let me ask, what's the best hotel with pasta? It's has given an error. It's not a major one though. We have been running the Ollama in background for so long. So yeah. So see, these are the results. The agent has suggested us some hotels which has got a good reputation for pasta. So, yeah, that was it. If you have followed me till this point of this video, congratulations, you have made your first AI agent. Many more to go, I believe. If you face any problem while doing the project, you can reach me out. So, yeah, that was all from my side for today. We will see you in some other video, maybe.